Är vi redo? Yes, hi, welcome, nice to see you all. Again, back on our live session. Yes, I have it here. So today we're gonna listen to Paul and Stefan. Gonna talk about Stairway to Azure. And it's gonna be really interesting. I'm looking forward to it. Small reminder to everyone online and everyone here, if you're gonna tweet, post on Instagram or LinkedIn, please use Azure Skåne. It's nice to be seen out there. It's also good for future events for us. So today's agenda, welcome and intro. I think we passed that one. So now we're gonna talk about Stairway to Azure Cloud, but I just have some words to say first. Azure Skåne, we're now over 960 members. So constantly growing, it's really nice. It's all about learning new stuff, networking, having fun. Everyone is welcome. You don't have to know anything about cloud, but it's of course good if you have some interest in it. Otherwise, it will just be boring. This Azure Skåne crew, it's me, Johan, and Magnus. We had a lunch earlier today, talked about the future, big plans always. So, for the people, this is something that we realized during the pandemic when we had a lot of online events that people join from other places than Skåne, where we live. This is the small part of Sweden, which is Skåne. So I just wanted to let everybody know that's not from Skåne, where it is. And to tell you something of what we are famous for. We have a really cool building that's pretty useless. That's what they say, the people who live there. We have a extremely cool bridge that goes underwater, and that is extremely useful. Connects us to Denmark. We have the best player in the world, apparently, in Zlatan. And for everyone who's missed it, we have Malmö FF. And we're gonna meet Juventus today, 1 hour after this event, so don't miss that game. Absolute Vodka is produced, it's developed here and semi-produced here. It's produced in other places also, but it origins from Skåne. And we have a Microsoft Azure data center. There, that's the correct logo. So that's the stuff that Skåne is famous for. And as I said before, please make sure we are heard. Please use the hashtag if you're gonna tweet about this. Today we have a sponsor, Capiche. Thank you for being here, and thanks to Foo Café for always supporting us with our events. And now to some cool stuff. Everyone that's attending this event are eligible to collect a digital badge. For the people online, we'll try to post the link to you. But otherwise, if you have a mobile phone, scan the QR code, download the wallet, collect your badge. And it's a NFT cool thing made by Microsoft. Well, collaboration with Microsoft and Engine. Something we realized during the pandemic is that we lose connectivity, the connection with our community. So we actually have a Discord server, and it's starting to be really useful for people. What we share our learnings, problems, solutions, questions around Azure. So please join this one. Everyone's welcome. And that link is only valid for 7 days, the QR code and the link. But if you haven't joined it, please join, and let's solve problems together. So with that, let's get started. Wait. Oh, sorry. A word from the sponsor.
Hello everybody, my name is Anders Högberg and I'm from Capiche. We're the sponsor of tonight, that meaning that we're paying for the pizza and the beer. Hope you will enjoy it. Together with my colleague Patrick here, we are also very excited to hear Paul and Stefan talking about the mysteries of Azure and how to code it the right way. Capiche. We're a software company situated in the big brown building close to here on the way to the central station. And what do we do at Capiche? Well, we develop a web-based graph data application for life science research. That means that people using our software can actually speed up the processes in developing medicines and drugs and other treatments. So when I talk to our developers, of course they're proud to be in the front of their technical expertise, but they're also very satisfied with working at something that matters. It gives a sense to their code and the coding with a purpose, knowing that our inventions can save lives. So, if you have any questions about Capiche and what we do, please don't hesitate to approach me during the break. And
I have a question.
Yeah.
Do you use Azure?
Yeah, as a storage. Yeah. But over to the main speakers of tonight, Paul and Stefan.
Thank you. All right, am I audible? Like that? Better? Thank you. All right, it feels great to be competing with the MFF Juventus game tonight. So I guess people online and everyone here in my book, you're all heroes for choosing this event. So let's get started. We're going to talk about Azure today. And more specifically, we're going to talk about what it means to go from a more traditional IT environment or an on-prem environment and go to Azure in different perspectives. So I'm going to try to zoom in a little bit more on the software side of things. So basically, we're going to track a monolithic application in its journey towards the cloud. My name is Paul Ulvinius. I'm head of architecture at Stateful Sweden AB. We are situated here in Malmö by Gustav Adolfs torg. And I will not be able to stay towards the end of this event, so I will take a short Q&A at the end of this talk. I'll try to make room for that. All right, I'm going to start with the kind of zoomed out picture a little bit because we're starting with the boring stuff, but I assure you, we are going to get to the cool stuff, the software and the microservice stuff. But I just want to paint somewhat of a broader picture here because onboarding a cloud involves very many people in an organization usually. So you need the organizational alignment. You need full support from organization. Why are we going to cloud? It's good to know. You need probably some kind of cloud adoption strategy. Are we going big bang cloud? Are we going towards a hybrid cloud? Are we keeping our on-prem data center or not? Are we using multiple clouds? What development model do we need while onboarding the cloud? Probably need some new processes. Maybe we need DevOps teams and whatnot. Do we need some kind of alignment with the strategy? So perhaps some organizational change. Perhaps create new teams, new governance. You might need to look over the security stuff. because obviously new possibilities there in Azure. You might need a target architecture. Where are we today, and where are we heading, and how do we get from here to there? Cost management stuff, billing, track. These are just examples. There are lots of more stuff. HR, new skills needed. We perhaps need to work with our culture, create a more software or digitalized or software-driven mindset. And we have a huge chunk with cloud administration, obviously, who creates subscriptions, who creates resource groups, who creates all this stuff. So you could basically tell a journey. You could pick one of these topics, and you can tell you can describe a journey from any of these angles. But I'm going to not do that. I'm going to tell the journey from a software system perspective. So it's going to be a little bit more pragmatic and perhaps easier to grasp. So we're going to track a monolithic, from start at least, a monolithic software system and its journey through a couple of different steps, which we can call the stairway to the cloud. Sometimes described as the cloud native maturity model. There are different kinds of models to use, but I like the simplicity of this one. Stolen with pride, by the way. But I have my touch on it, so to speak. But this is basically the agenda for the rest of this part of the talk. So let's start with this monolithic app down to the right, or down to the left. So we have this app. It's an old, perhaps 10, 20 years, 20 years ago it was built. It's stateful. It has infrastructure dependency, like it can only run on Windows, maybe a specific version of Windows. There is no possibility of test automation, and it probably handles lots of different kind of things. So it creates users, it works with products and order flows or accounting. It does all kinds of things, and you can visualize like a huge user interface with a tree menu and all kinds of crazy things. So this is what we need to completely remake to fit Azure, or a cloud architecture, basically. So this is our application. It's a pretty traditional one. It has a user interface. It has some kind of server side component, which is the monolith that does, in this simple example, does three things, perhaps: handles users, products, and orders. It has a database, which typically resembles what it does, right? So it's, again, you could picture it has a orders table, a products table, or orders is twice here, I see, but users should be user table. The first step towards the journey to the cloud is the what we call here the cloud ready step. So basically, it's when you complete this, you have not yet optimized for the cloud, but you have kind of made your monolith more prepared to onboard the cloud, to make it possible. And I almost forget, in theory, you could actually move even this app in this state to the cloud. But only way to do that is like a complete lift and shift approach, where you basically take the same infrastructure as you use on-premise in your current data center, and you basically lift and shift it up to the cloud as is, with all the bits and pieces needed, all the dependencies, everything. But it's obviously one way to onboard the cloud, but you're not using the cloud. You're basically moving the stuff from one place to another. You're changing the data center from your own, perhaps, to the Azure data center, but you're not using any Azure-specific or cloud-specific features per se. but after this step, you could do it in a more sophisticated way, if you will. So it means, first of all, you should try to make sure that you have stateless processes, so that you don't have long-running processes or processes that can't scale. Because this is about the cloud is a lot about scale out. Because you want to use many machines are cheap. There are many machines in the cloud, so we better make use of them. So you need to go stateless. You might have a code base with lots of different applications, and try to extract one. Try to extract the application code base from the overall code base in your organization and make it a single code base for the application. Because you need to start to be able to automate stuff down the line. I'm going to get to that. Service abstraction. This is about perhaps refactoring. So if it's a monolith, it might have some kind of spaghetti code. It might have all kinds of dependencies in the code base. And you need to be able to, you need to start kind of abstracting things away, basically. This is going to be really important later on. Package management is a good idea to do already now. It's a matter of security for one, but it has several different meanings also with going to cloud. Dependency management, so basically what you have abstracted away your services, but you also need to abstract away your infrastructure, like the way you log or the way you save stuff to storage. So this is one gigantic refactoring step, if you will. This also enables you to start using unit tests and stuff. So the unit test part might be considered as some kind of benchmark. So if you have done your abstractions right, then you can start unit testing. So it's like a test if you're cloud ready. Some examples of technologies that would be typically involved in this step. Unit testing is important with, Visual Studio and Visual Studio Code is obviously strong on unit testing. NuGet for package management, GitHub or Azure DevOps for the code base stuff, and starting to structure your code base and your development process. So we're gonna take this application one step now. The stuff in the colored or orange or whatever color it's supposed to be is the new stuff that I've added from the last picture. So first we're adding a service layer here. This is internal to the monolith. So you're kind of starting to abstract away stuff. So all the communications that comes from the application GUI has to go through a service layer abstraction before it can't use the different modules or parts of the application directly. It has to go through a layer. And then the storage provider, or you might have several, is also a question of creating abstractions, but this time towards the database itself. So you're creating internal abstractions, and you're creating abstractions and interfaces towards your storage. This is really important. And many monoliths already have this, so it's not sure you have to do this, but if you haven't done this, you have to start doing that right away. And to the right there, service providers, two different examples of services that you might use in your application: logging, caching. There are more examples, but also abstract away stuff like that. So no dependency to your file system, no dependency to whatever logging service you have, but always talk through these interfaces instead. So if you have done this, you're in a much better shape overall. This is good to do anyways, even if you're not onboarding a cloud. But this is kind of bread and butter stuff that you have to start with. And all of a sudden, you might already now swap the database for some kind of Azure component or any other part. You might use a logging service from Azure or caching service, because now you've started to create abstractions, which means you could swap out the dependencies. So already now you could actually, in theory, start using the cloud in an intelligent way. So the next step is the cloud enable step, which basically is that we're actually utilizing the cloud. We're using the unique features or benefits, if you will, with the cloud. We've started to use these features. So this is basically, we're laying the groundwork for utilizing the cloud in a more sophisticated way. So these steps include to externalize some even more stuff like configuration, and credentials, secrets, so any kind of connection string or any kind of password or whatever secrets you have has to be excluded from the code base, basically, and be completely externalized. Same for configuration. So it's basically taking the refactoring of the application to the next step, to the next level. You have to be able to start scaling your application horizontally, or scale out, so to speak, because this will obviously be important in a cloud environment, which is all about scale. And also, if you have maybe you have a manual release process, you need to start to automate that, and you need to all the stuff with all the code or all the scripts related to design, build, and release needs to be separated from the actual system itself. That's a really important step. And also the last but not the least is going environment agnostic. So before, this was a Windows version X whatever specific monolith or system, but it should be able to run on Linux, for example. So we're adding stuff here to the picture. We're adding, to start from the left here, we're adding environment agnostic code. And this could be a matter of upgrading to .NET 5, for example. It doesn't have to be more than that, because that provides you with the environment abstractions already. There are other ways, but that's probably something you want to do anyways, right? To upgrade to the latest version of the framework. So all of a sudden you can perhaps run on Linux. You don't have a dependency on Windows specific features or the registry or any of that stuff. You're only using the SDKs and the framework. You're speaking through that, which means that you could actually start using different environments. You can even put this server application on several different nodes or servers already now. Because remember, you fixed the statelessness already. So you could already scale now. Perhaps not in a fluent manner, we're going to get to that, but you could actually scale perhaps manually at least. And then configuration and credentials to the right, basically the same pattern here. You're basically adding more service providers to handle externalized configuration and externalized secrets. An example of that in Azure could be for credentials and secrets is obviously Key Vault. So you could already use that now. You can have the application itself run on premise, and you're still using Key Vault in Azure because it's abstracted away. Or you're using application configuration components in Azure. You might use caching services or whatever in Azure at this point, in even the database, like we talked about. Or the opposite, you could run this server-side application in Azure, and then the database could be still on-prem, which is also a not so rare pattern actually, because of you might not have the legal grounds to move the database itself yet. there might be a legal discussion going on, so you might have to, or a policy wise from your organization, you might be forced to have your database on-prem, at least for now, but other components can start move to Azure at this stage. Any questions so far? Pretty clear? The next step is Cloudcentric. This is where we kind of go towards more heavy use of the cloud. And we're starting to use all the features, the tools, the platforms that are provided. After this step, you would typically be more fault tolerant and have more resiliency. You would perhaps add telemetry support and more proactive failure testing. Perhaps you'll set up a integration testing in an automated way for your application. So we could imagine some more tech in our stack now with perhaps some application insights and Azure Monitor. Azure Monitor is more for the infrastructural kind of information or telemetry. Application insights is more for the application-specific telemetry. You might start using containers. You might be able to put some kind of load balancer in front of the whole thing, because now you can scale, right? So you can divide your application. You can load the balance between different clusters. And you can start describing your infrastructure with a Docker file and stuff like that. So you've gotten pretty far now in the journey, so to speak. So we're swapping out the hard-coded servers, if you will, with some kind of perhaps container orchestration. It could be Azure Kubernetes services, for example. So now you can scale. This container orchestration has these kind of rule sets where you can say that I always want at least 3 nodes, but never more than 10, because it's gonna cost money. You can describe your infrastructure in a kind of declarative way, and then it'll take care of the infrastructure for you. So it's more fluent in that way. So now you have an application that is completely agnostic to all services, all infrastructure, and all storage, basically. It's one way to think of this is that you have kind of shrunk your application and externalized more and more stuff from it, offloaded stuff from it, to make things more flexible. So this is the trend that we've been working in. All right. But it's still a monolith, I would say, because it's still one application that has all these responsibilities still, right? It handles users and products and orders. It's just an example, but it does several things. It does lots of different things. And it's still attached to some kind of database, even though it's architecturally kind of nicely layered. It's in runtime, it still uses one gigantic database. So it's still a monolith in that aspect. So the last step here is the cloud native step, which is basically where your architecture is fully aligned with the patterns of the cloud. So this is perhaps, well, it basically depends, but this is where you're gonna live. So this is where you're gonna spend most of your time once you're there. This is the final step, so to speak. So we're gonna look at how to break this up into a microservice architecture. We're going to talk about the API first design, what that means for this application, and how we can use async patterns to make things more efficient. So let's start with the first some tech stack first. Okay, so you might, for this, you might end up using basically all platforms in Azure, but it depends on the application, obviously. But now, if not before, then now you might start to introduce some more higher level or microservice specific kind of platforms, if you will. Some of these at least are like Kubernetes. You might use logic apps for orchestration. You might use Azure Functions for smaller services, Event Grid and Service Bus for the async patterns, and Cosmos DB, which is obviously more popular now with microservice architecture because it once you break up these monolithic databases with relational tables, and you're end up with a one table solution. You might wonder, do I really need a relational database if I don't have any relations in it? So that's often where you kind of enter more document databases or other types of databases. Well, that's one reason. So this is where it starts getting interesting. Just a short time check. How am I on time? 15 minutes left. Excellent, thank you. Okay, so since we have kind of abstracted away everything now, we can start creating some more sophistication here. So now we removed the orders table from the database, and we put the orders table, if you will, in a separate database and put an API in front of it. And it might not even be a table. It might be a document database. It might be something else. It might just be a file storage, depending on what it is. Because if you isolate one component, you will find yourself being in a completely different kind of environment altogether, obviously, which means you might not need relations in that way anymore. So it might be a completely different kind of database. It might have a REST API in front of it, and it only handles orders. And once you did that, then you could easily just swap out the database calls from the storage provider from before, and now swap that to an HTTP client, because now you can start talking with an API instead. So when you are creating new order, instead of going through the database to create a new entry in the table, you basically make a call to the REST API saying create order. And we might continue to do this. This might be a long process. You could easily be in a situation where you're partly using microservices. Maybe you abstracted away the order stuff, but you still are using the users and product stuff for perhaps 2 years or something before you continue this journey, and it'll eventually end up here. So doing it in this order that we've talked about now kind of creates this ease of mind. You don't have to necessarily to rush things. You could easily just pause here for a while. It'll still work. But the target architecture probably says that you want to go all in microservices, for example, if that's what you're doing. So now this has become more of a backend for front end. I don't know. Have any of you heard of that pattern before? It's a pretty common pattern for microservice architecture, because this application now doesn't do kind of half of the stuff that it did before. It basically directs calls to these other APIs now. This service now, the user service, we might call it, this has the responsibility for handling users, creating new users, upgrading users, deprovision them, whatever needs to be done or supported by the organization in relationship to users is now this specific service responsibility. And you are now only a client to that service, right? So that's an important concept too. We have kind of went full circle here. So we have this has a completely different role in the architectural landscape now. It's basically some kind of it's more aligned to the application itself. So that's why we often call it backend for frontend. It's a front-end specific backend. It only exists to serve its front-end, right? So it has probably, if I think the next picture is, we might add an API in front of this one to go all in with the API kind of design. And the endpoints in this API would typically be very application user interface specific. So they are there to support the different views in the application. They might change rapidly because now we're changing the looks and feels of the application. You need new support from the API, which is completely fine because since this application only exists to serve this particular application, you have no issue there. And note that you don't have to change the APIs of the core systems anymore, so they remain the same. So now we're zooming out one step from the picture, and we're looking at 3 different applications. We could picture that these 3 applications had the same kind of journey, perhaps a little bit differently from each time. But one of them might be a smartphone app, one of them might be a Windows desktop app, or whatever, a web app. So now this is where you start to see a pattern, because you have these applications, they have their own dedicated backends, which we call BFFs for short, backend for frontend. And they have their APIs, which are application-specific APIs. And then you've started to create this ecosystem of microservices, basically, where their APIs are more slowly moving. They are more CRUD-like in nature, like the operations they support are typically create user, delete user, update user, create, update, delete stuff. Perhaps some more sophisticated or higher level operations, but still probably along those lines. So it's very common to look at these APIs when you started to enter the API economy or API architecture. When all kinds of APIs start popping up, it starts to get important to separate. I mean, you need probably different policies and security layers and stuff like that for the inner APIs than for the outer APIs. The outer APIs might be talking to the internet, but these inner APIs might not, for example. So, but here's what we have kind of, there are lots of gains here that we haven't talked about. So obviously now we've created a information sharing architecture, right? Because before, the product table that was locked into a monolithic database that was only used from one single monolith application, it was basically locked in. And no one else could create users or could create products. If you're building an app and you say, I want to create new users from this app, you couldn't do it. You have to go through this user interface from this monolith. But all of a sudden now, you have these microservices with APIs that are completely autonomous. And you're perhaps writing, 2 employees might have developed a new smartphone app. And they want to be able to create products, for example, through this app. And now they can do that. Just as your old monolith that is now a backend for frontend, you could perform the same operations from different part of the from the different parts of the architecture. And now we have also introduced eventing and messaging down there, which means that, which is obviously very common in microservice architecture, which basically is a way for these microservices to notify the surrounding world, if you will, that something important happened. which means that anyone could. So if this smartphone app now created a product, maybe you have the different kinds of application or scenarios that they are interested in knowing when products are created. So that means that this application, perhaps your old or our old monolithic application, still wants to know when products are created to perhaps update the user interface in real time or whatever. So this backend for frontend can now subscribe to these events. So this is kind of the new ecosystem with loosely coupled messaging through and the information flowing back and forth through a microservice architecture. Some more tech stuff here. These microservices could be implemented in several different ways. They could be Azure functions. They could be Kubernetes like containers or pods. They could be Azure App Services. There are several different flavors in Azure to do this. Kubernetes is probably the most common one today because there are a lot of tooling and lots of community support for creating microservices in that ecosystem. But also what we've gained here is that you can have different tech stacks in the different, because they're completely autonomous. They're completely independent from each other. This one might run, Python or whatever. And this one is C# and Java and whatever. And different databases, you're completely free to optimize whatever part of the architecture that you're in. And different teams might handle the different components. So you have the Python experts, they're working over here perhaps, and you have the C# guys, and that's fine. You don't have to align all the tech stack, so it gets more dynamic that way. Also, you can upgrade this entire API to the latest NuGet packages or whatever. It won't affect the other guys. Oh, and I have down there we have some eventing stuff in Azure, Event Grid and Service Bus. I also sneaked in some API management there. It's really obviously important to have a kind of a coordinated way of publishing your APIs when you have lots of them. And Azure API management is an important component in Azure, a native component in Azure for publishing your APIs and manage your APIs in a secure way, an efficient way. Right. So in summary, because I have a feeling I'm running low on time. So there are many different aspects of moving to the cloud, like we talked about on the first slide. Strategic, security, economics, organizational, all that stuff will probably go on in parallel with all the stuff that you are doing. But it's important to have this broader picture. The cloud migration journey for software systems are unique for each system. There is no blueprint. This stairway that we talked about, you probably have to squint a little bit when you look at it, because it's not going to be 100% correct for each system, but it's a way to frame the problem in a higher level. And Azure is I like to see it as a mosaic of specialized platforms or Lego pieces that you build your software on top of, which are kind of managed Lego pieces, so more specialized and handled for you. Microservice architecture can maximize the utilization of the cloud, like we talked about in the last slides. This is where you get when you end up here, this is when you can squeeze out every inch of the cloud, right? You can lower the costs because you can optimize you chose perhaps the SQL database in this API, but not in this, because it actually fits better. So you can make more informed or resource efficient decisions because you've started breakups, things like this. So cost and security, because you've started layering all the stuff, and the user's API. No one knows better what the security should be for the user's API than the the guys that work with the user service, for example. So they know that domain, so to speak, and compare that to where we started off in the monolith. You have to know everything. You have to be the user's expert. You have to be the product's expert, because it's the same system. It's the same code base. So everyone has to know everything, and it's not feasible. Probably not human in many cases. Operational agility, speed of innovation. You will be able to handle stuff that pops up more fluently and react when stuff happens, and innovate. And cloud is a lot about innovation, I would say. That's where it shines. Right, that was pretty speedy. I was probably talking too fast as usual. Was I landing on a okay time? I don't. All right. Excellent. That's what I was hoping for. So, did I cover everything, or did I leave some of you curious?
I have a question. I think you have to repeat it then. When you talk to a customer, how do they go from the decision to break down the monolith into microservices? What are usually the breaking discussions?
Yeah, so the question is, if I get you correctly, that what are the typical decision gates, or what are the typical the hard parts of that conversation where it hurts? I would say already at the start of this whole stairway, because you need to have a clear vision of where you're going. It's not like you can halfway decide that we're going to a microservice architecture. I don't think that's the case. You need to have that picture already from start, because otherwise you're going to make all these kinds of inefficient decisions along the way. So you have to have the target architecture somewhat in place, not on a solution design level, but in a general way. But that means that the discussion that's going to take place from start is going to be harder. You're probably going to have people, not agreeing on what pieces comes when, so to speak. Do we really need to refactor everything? And then you're gonna end up with trying to convince perhaps the company that you work for, because refactoring on this level that I talked about is really expensive, obviously, and it might not be a return of investment until like 3 years into the future, and that planning horizon is pretty rare, depending on where you are. So you have to break up some. I described this is kind of the happy case, that you could do all this stuff in very distinct steps. So now all the refactoring is done. Now we can go to the next step. In reality, probably not, right? Probably you're gonna have some different discussions and some different priorities along the way, and some stuff will not end up the way you want. So yeah, already from start, I would say, lots of discussions.
There's some questions coming in online.
Mm-hmm.
What would be the main driver for moving to cloud?
So I think it's about, for me personally, it's... Oh, yeah. So thank you. So the question is, what's the main driver for moving to the cloud? And for me personally, I would answer that it's about speed of innovation and security. Probably security first. This is actually, many people react when I say security first, because there's a lot of talk now coming probably from the legal side of things, that we don't dare to move to the cloud because of security. I would argue the opposite. This is a new talk, so I won't have time to elaborate on that. But the opposite is actually true. So when you do it right, obviously, as is with everything, the cloud is a much more secure environment and architecture to for lots of different reasons. And speed of innovation is the second motivating factor for me, at least, which is the ease of creating a new environment, testing, trying something out, a new technology, and just after like a couple of days realizing that, oh, this was the wrong thing, let's try out a different thing. You could never do that with traditional IT when it takes like 2 months to order a web server or whatever. So yeah, those two things, I would say.
That leads into another question.
Excellent.
Many of those components you showed can be run on premise also.
Right.
What would be the benefit of running it in cloud compared to?
Well, it not, might. Okay, so the question is, some of these steps or components could just as easily be run on premise as in the cloud, which is completely right. And it's not even sure that it has a benefit in each circumstance to move a component to the cloud as soon as you can. You might it might not be just because you can do something, just because in theory you could swap out that database in the earlier stages to an Azure database, doesn't mean that it's the right way to do. You might not end up with a situation which is more beneficial. You just swapped out a database. Perhaps it has some kind of reasoning to it if you know that you have to do it eventually anyways, and now we have time to do it, but not later, then that's one thing. But otherwise, it's not sure at all. So you might still run stuff on premise for a long time. So it all depends. This is very highly contextualized, I would say. Yeah.
And a last question. Is there any thoughts about vendor lock-in when building these services? If you use functions, for example, you're pretty bound to using functions compared to if you would build it in Kubernetes.
Right. So yeah, this is so the question is there any risk, or how do you reason about vendor locking? So this is an ever-going discussion. Obviously, it's again 1,000 parameters that informs these decisions. So it's hard to generalize, but we have seen a kind of rapid movement with the microservice architecture and Kubernetes specifically, and the ecosystems that of tools and platforms and architectural patterns, like sidecar patterns and stuff like that, that has kind of sped up the whole innovation around cloud agnosticism, which is more of a thing today, much more of a thing today than for 5 years ago. So I would say Kubernetes is one of the main drivers technology-wise to speed up that innovation. And obviously, if you can choose between two options and they're equal, and one is cloud agnostic and one is not, obviously that's a benefit. So you would choose the cloud agnostic one. But that also comes the other way around. If you are using Amazon, you might come over to Azure because you're cloud agnostic, right? So it goes both ways. So it benefits everyone probably. So I think this is a really important development. But for what many people miss is that being cloud agnostic is not only about the containers. If you're going to be 100% cloud agnostic, then you have to be honest of what you're using in the cloud. Are you using Key Vault? Are you using Azure Functions? Are you using configuration stuff? You're probably using more than you think that is externalized to the container itself. So at least be honest in that discussion. It's not enough to just move to Kubernetes to be cloud agnostic. You have to consider all the different aspects of your code base. So it's still not as easy to do in practice. Cool. Right. So thank you very much.
På den först kanske. Så. Funkar den nu eller? Går det bra? Strålande. Okay. Hi, welcome to the second part of this talk. I will talk about a little bit about high security cloud solutions. Who am I? I'm Stefan Strand, working as a senior architect at Stratitech in Malmö. I have 20 plus years of experience, and I am passionate for innovations, and I am hungry to learn more. So, but let's start. Today we are going to do a dive into the cloud. So it looks really nice here, I guess. So the first thing that I think about is the digital package. And a digital package of data can be in 3 different states. Data at rest, data in transit, and data in use. And I will talk about this during all the session, more or less, and about encryption in all these 3 states. If we are going to explain it a little bit more, this is a traditional internet web application, more or less. To the left, we have a user client who have a web browser. Clicks at a link, it communicates over internet to a web server that gets the data from some kind of data source, a database or a file in some place. And so there is a communication inside the server-to-server communication. And then it goes back again. So that is a typical web page request, more or less. And if we look at in the bottom of each rectangle here, you can see that to the left you have the data in use. The end user uses the data. Data in transit. The package is in the car, and then you have in the web server. It's opened up again, the data, and it's transferred to the data storage. So we are not going to talk that much about the two layers here, the data in transit, because that is quite common. You should always use encryption, HTTPS only, I would say. Also, within the intranet, you should have TLS encryption activated. So force that in the web browser settings in some way, or in the computer policy. That's my recommendation. You should only use security updated hardware and software. If you have old NAS and other stuff, it might be the case that they are not that safe any longer. So and IoT devices that are quite common today, they are also at high risk as they get older. VPN, virtual private network communication. I would say that if for your own privacy sake, use it also at home. If you haven't tried it, you can try it. expressvpn.com is one good way to do it. Netflix from US, for example, if you need some other series that hasn't come to Sweden yet. So try that out, and of course for important traffic to the companies, you need it also. And the firewalls should of course be configured to only allow needed traffic. And then I would say that the employees are not that good at configuring their own home networks. So please help them if you are good at network configurations, because if the home networks are weak, then you might get problems with connected devices into that. So so no more about the in transit. Use HTTPS. If we look at the data at rest, it could be in a database or files or anything. If you look at Azure, the normal thing is that you have one layer encryption. So if you create the data storage, Microsoft encrypts the data automatically, and that is good. But as you see in the bottom here, you need to trust a lot to use that service. You need to trust US government, Microsoft, the company IT, the solution owner, other end users. A lot of trust to get that safe. With a very small configuration, 5 minutes away or so, you can add one more layer of encryption. You have to do that when you create this data storage, but it's only 2 checkboxes. And then you can have Microsoft encryption together with your own IT personnel encryption, if you use Key Vault, for example. If you encrypt it in that way, then Microsoft and the US government will not be able to get your data anymore. The company IT and the solution owner and other end users will still be able to be a security risk. If you then add even more, one more layer of encryption, so that the end user also encrypts the data, then you will have 3 keys, and you will basically have a totally secure solution. And that is what we are going to demonstrate today. And you can actually take it even further and have any number of layers of encryption to meet all the hierarchy levels of the needed trust. For example, it could be you can have a software as a service function, and you have many customers in that solution, and then each customer could have their own keys, for example, so that no one can get the data. If we start to the left here, it's cheap and quick to start up with standard Azure default. You have every feature available. It's not approved for GDPR. It's a problem for governmental data. Data is not stored in Sweden yet. I guess soon in Staffanstorp we will have it. Cloud Act. Everyone talks about Cloud Act. It's a problem here. If we have two layers of encryption, it's still not. It's a question mark about the GDPR and governmental data, but it might be okay for some data. Data is still not stored in Sweden, so that's a problem. You need to add some key handling administration, not that much, but a little bit harder, of course, than one layer. When it comes to 3 layers, it will be a bit trickier because you need more key handling, of course, and some features are not available within that solution, and you have to develop it yourself, more or less. If we look at the last to the right here, it says n layers plus hybrid, and that means that you can have any number of encryption layers, and you can also use different cloud providers, and you can use also on-premise solution together, all in hybrid. Then you can, that solution is approved for all data. You can store critical data on-prem if that is the case, and you can store non-secret data on one layer encryption, and you can have it together in a good mix for the maximum features and high security. And in that layer, you don't trust anyone, and you separate the data. How to activate the 2-layer encryption? It's only 2 checkboxes that you have to fill in. A couple of links here, and then you have to create and configure a key in the key vault, and it takes 5 minutes, and you are going from 1 to 2 layers. Yes, now we are going to dig into the demo. I have created a website to demonstrate this, and it uses 3 encryption layers. And as you can see here, the data in transit and the data in transit, both on the server environment and at the internet is green. That's because we have it encrypted. And now also the data storage to the right is green and safe because we have 3 different levels of encryption. And in this solution, I don't use traditional web server. Instead, I use a serverless REST API to serve the pages. So this is the application that you will be able to access on your phones soon. The technology used is, of course, HTML and style sheets as the base. And then a serverless microservice architecture is used, and I have used Python Azure Functions. So Azure Functions in Azure and the Python version of that. I also have used traditional blob storage to store files, and I have a key vault used, and some extra Python packages. So this is 100% done in Azure, and I just looked it up, and the cost for development and some tests and so on is 1 Swedish krona. So it's quite quick and cheap to get started. Like you said, Paul, speed of innovation. Yeah. Good. And the cost of it, of course. Yes. So, next slide here. Now it's time for you to take up your phone or computer, if you have that ready. And then you are going to put in a long web link here. Quite easy to read anyway. It says HTTPS, of course, and then website example storage .blob.core.windows.net /html/demo.html. Anyone got it working? Yes. One at least. Yeah. So I will go through, guide you through this when everyone has got it up and running. Okay. It will be stated in the bottom here all the time, so if you didn't get it before. So I will explain it shortly. There is one, there are three parts actually. The left part is where you generate keys. And the second one is where you put in your data that you want to encrypt, and then it is stored. And the third one is where you list your created data. And if we start with the left session, so you can just click on the generate new keys, and you can see that the public key and the private key updates. It works. Yeah. So in this case, this is I have used a Python RSA package to encrypt it in a 512-bit asymmetric RSA key. So this will only be able to encrypt around 50 characters of text. It's not used for big stuff, but it was fast too, and yeah, you understand how it works. You have the link to the more information about the package to the right. Yes. And now I will explain a little bit about the web link. That's why I kept it as it is, because here I have opened the Microsoft Azure Storage Explorer, and that's where the files ends up. And the first part, website example storage, that's my name, good name. You can see it here. That's the name of the storage, and the type of storage is a blob. That's why it's blob. And then the core Windows.net is standard Azure. And then I have a container in here that I have named to HTML. And inside that container, you have one file named demo.html. And this is a static HTML file. So, and that is possible to use without anything else. Just put a file there and you have a web page working. Yes. And if we go to the second part of this site, you can see here you can input data and you can see the store data. So if you first put in some data here, hey or something, anything, and you save it, then it will be saved without encryption. So that will be a 2-layer encrypted data file. And if you do that, I will be able to pick it up on the server and read it. So I, as an IT admin, will be able to read your data. But if you instead pick your public key, copy it from the left side, the first frame you had, where you have the public key, everything within the public key and the number to the end. Put it in here and then click save. Then it will be stored as an encrypted text. And if you have done that correctly, it will save 2 files. One which is named with a generated GUID. A new GUID, a file name here. And then the other one is named the same plus public key in the end. So there are 2 files. One file contains the encrypted data and one file contains the public key. The public key is nothing secret. That's why it's named public key. So so that means that I can match these two. I know which key is related to each file. Yeah. It works for you? Yeah. If I open this in at my side, the public key will be in clear text. That's not secret. But the content in the other file will be encrypted. So I can't read it. Microsoft can't read it. US government can't read it. And if we now go to the third section of this little demo, we have the stored data section. If you copy the private key here, that's much longer. It's 5 parts instead of 2. So copy all that into this text box, and click at Get Data. Then it will match your private key with the public key files and list the files here and decrypt the text. So it will end up here. It's a little small, I know, but that's because I wanted to have it in one small page. So maybe will start. Okay. Yeah, it's a prototype. Yeah, and it worked. And if you try to do this again, add a new one, it will end up as two rows here. Yeah. So and now, now we have a solution where you have 3 keys or encrypted the files in 3 layers, and you can pick any kind of encryption method or algorithm in each level. Yeah, not Microsoft level, but the other one you can. So it will be even safer if you want to. IT. Yeah, IT key. The IT key is the IT department key. Also, that's what we're testing now. You enter the user key. So IT key I have configured in Key Vault. So that's I have already done before. So but it's like Bitcoins. If you lose your end user key, the data is lost. So and now we don't save the keys. So if you refresh the first page you have, then you will lose your keys. You will get new ones. So you need to store them and handle them in a good way. Yes. And if some quick takeaways around this, I would say that you should use encryption. Not everyone uses encryption, especially not on-prem, but I would say that you should use it on-prem also. Computers or quite often use BitLocker. That is of course good, but many file servers doesn't use encryption. It's a bit harder to back up and stuff like that, but I would say that you should use that. And I would also say that you should limit the security built on trust, so that you basically don't trust anyone if you don't need to, and design for privacy and security. So if you classify your data, then you can put it in the right context and use the right level of security for each data type. And you should use also educate your employees and password managers. How many here have password manager? 1, 2, 3, 4, 5, 6. Not that common, but yes, please do use that. And when you build solutions, don't implement export to Excel too often, because then you make it very easy to spread the data, and if it's secure data, it shouldn't be spread. So, but that is the first function that business user ask for. So, I want to export to Excel. Okay, if we take the next level, data in use, what is that? That is, for example, in Azure Function Service. That is a service that is shared between a lot of functions. So my function is used uses the same hardware and server as your services. So they share CPU and internal memory, and that means that they will be able to sniff between the processes if there are some bugs, and if you are at the right side of things, then you can look into what different other processes are working with. So that means that you don't. There is no. You have to trust a lot here also. The risk is not that high. That's why it's yellow here, but it's doable. And if you are a hacker that finds some weak spots in the software, then it will be quite easy, I guess, to use that. But instead, there are something that Microsoft call confidential computing, and that's when each process uses an isolated part of the memory, and it's encrypted. So the different processes cannot read the memory. And the hacker will probably not attack you if you do go that way, because it's much easier to go to the yellow stuff than the green stuff. So you will be quite safe. There's still some trust level at the developer of the Azure function. You need to trust me and other persons that develop things. There are some ways to come around that too, but yeah, we don't go into that now. Have you heard about this kind of encryption of the data in use? You have heard? No?
How can you be sure that it's encrypted? Do you have to trust?
Yeah, of course. Of course, they need to do that in some way. But they build this on top of Intel's SGX technology, which you can read things about. There is a link here for intel.com trust SGX. That's a good starting point of the technology itself. And then there is a lot of it on Azure to explain how it works and what it is. So, but basically it's the short explanation, as I say, is that the RAM is encrypted as well during runtime. So, and that makes it much harder. Not 100% safe. There are, of course, bugs in that also, but much harder than if you don't use it. And today, as I looked it up before this presentation, virtual machines, that was the first thing that came. I don't know exactly date. Anyone here? No? No?
I think since at least a year ago.
Yeah, I think AKS, Azure Kubernetes Services, was 1 year ago, and virtual machines must have been before that.
Yeah.
I read about SQL database, Azure SQL database. I haven't heard that before. I read it today, actually, but I understood that it's a limited functionality in that. So you can't use it on everything. You can't perform all queries and so.
You use it together with something that's called always encrypted in Azure SQL databases.
Yeah.
So it means basically that you can process encrypted data on inside Azure, which you couldn't without confidential computing. So it's you use it together with this always encrypted feature.
Yeah. Good. But I think that there will come more services on the long term. Yeah. So if we do this, then we of course, you can use confidential compute. It's easy to if you have a virtual machine, you can just pay a little bit more, and then you have it more or less. So use it when it's needed. It's not working on all services, as you saw, but you can have Docker containers running this, for example, and then you can basically do whatever you want. But it's easier to use traditional services, of course. But you should always limit the data processed anyway to be secure. And if you don't need to look into the data, so then you can scramble data also to make it even safer. Yeah, and that's basically that. So now, if we have also this serverless REST API running in Kubernetes cluster Docker container, because Azure Function is actually an open source package around that, so you can do whatever you want with that, and then you can you have an end-to-end encryption where you don't trust anyone. So you send data from your client, and you can get it back, and no one can read it on the way, and not the stored data. So that is basically an end-to-end encryption. As a summary, encryption is available in all states. Data in transit, we always use HTTPS. Data at rest, we normally use encryption in some way. Data in use is new, and that is something that will come probably more and more. It's easy to start. Why don't you start small and try it out, as I did here. 1 Swedish krona and a little bit at a time, some hours. You can grow step by step, iterative development. And as Paul said before, microservices architecture, it's cheaper. You can be independent on cloud providers, and it works also on-prem if you do it in one way. And it simplifies building hybrid solutions specialized for your needs. So any way of encryption layer for each service. And I would say that it's important to keep your knowledge updated, because there is quick movements here. So So thanks a lot for me.
See, do we have any questions? Just going to check online if anyone has any questions. No, there's nothing special online. Well, I have a question then.
Yep.
So in the function case, this is more about the encryption on the almost hardware layer. How do you have any tips on securing, like in code level, for example, the functions? You would have the managed identities and RBAC. This is a level.
Yeah, this is only about these 3 steps or states, the security on these states, in rest and in transit and in use. So there is a lot of more security aspects in this.
So if we go back to what Paul said that in the beginning in some discussions was like we can't move to cloud because of security, but now it is we need to move to cloud because of security.
Yeah.
But the default level of security enabled, is that kind of the standard that people think is good enough? Or because this requires some heavy decision making, at least if we're gonna use secure enclaves and so on. Is this typical?
No, I would say that the typical is that you don't have that much need for more security than the private, the default. But when you talk about GDPR and defense data and stuff like that, then it's definitely not enough. So this is some ways of doing that. And GDPR data is quite common, actually. I think more or less every company needs that. And if you needs that. So why not use more secure solutions when it's easy? Yeah, so 2 layers is, I would say, why not? It comes, of course, with a small cost. We need a key vault, and that will cost something. But it's not that much. The one layer, yeah, okay. If there is a performance issue by using, if we have noticed that, yeah. The standard solution is no performance issues at all. The second one is not a performance issue. So if you have 2 layers, that's not a problem. But if you add this user encryption solution that I added, where you encrypt text and put it in a file, that is, of course, that will impact the performance a lot in that solution. But there are a lot of other solutions available where you can encrypt files and in other ways that will be faster. And maybe all of you have BitLocker on your computer as well, and you don't notice any performance issues with that, I guess. Yeah. Each layer will, of course, add some, and also the type of algorithm that you use and how many bits you encrypt with, also. So, yeah. Yeah.
You mentioned home networks and IoT devices.
Yes.
What about if they're not internet facing, the IoT devices?
Yeah.
The servers, for example. Would you still recommend using HTTPS for home users? Is that not needed?
Oh, okay. The question was if you have IoT devices at home and you use HTTP instead of HTTPS, is that good? Good enough? It's not internet facing. Yeah. Since it's not on the internet, then it would be quite okay, I guess. But you are more people on the network, I guess, than you, the family, and maybe some friends, and everyone share your Wi-Fi. So yeah, maybe you don't have that much secure data. So the problem is when the IoT devices have connection to the internet. That's the big problem. Then you need to have them in separate networks, and have them configured in a good way.
Question is always how much harm can it be done, right? If you don't
Yeah.
mind lights going on and off,
Yeah. Pacemaker. Maybe not that good. Okay, no more questions. If that is the case, then the game starts in 1 hour or something, I guess.
Yes.
Yeah.
I will just
Yep.
try to. There. Nice. Thank you. Really interesting learning about security and microservices today. And yes, so for everyone that missed the badger, you have another chance now. Claim it. It will be useful sometime in the future. Can I see it now? Hopefully, yes. So yeah, please claim it. It's valid until tonight sometime, I think. And then if you want to continue this discussion, join Discord. If no one's there, I will be there. So and answering, but it's becoming really like my go-to tool. I have all really cool links useful links, status of Azure daily, updates, all of it, it will be there. So please join it and accept the welcome message. Should I go back? No. And yeah, that's it for today. Thanks for being here. Nice to see everyone. And keep in touch. Share on social media. And welcome to next time.